This is the lesson 2.7 visual summary that really wraps up everything that we've learned in all of chapter 2. So we have a table, we have a graph. So it's asking us to graph, and it gives us bullets here. So this is exactly what we're looking for that you include when you graph. So it says place an X and a Y on the appropriate axis. This is the X, this is the Y. Label the X and Y axis with units. So number of tickets purchased is the X. I'm going to actually just write it off to the side. Number of tickets purchased. And the Y is the total cost. So over here, I'll put total cost. Label the X and Y on your table. Here's my X, here's the Y in a table. Number the intervals on each axis starting at the origin. So this is a little difficult because here's my X. My X is the number of tickets. So I see I have to go out to 10. There are 20 lines here. So I always want to maximize my graph. That means I could do every other line. So this is where I'm going to do 1, 2, and just keep going. Let's get every other line. If we don't maximize, we end up with everything crunched together for our graph. So origin, that'd be my 0. Now when I'm going up, I need to go up to 150. So I think the best way to do this is I take a calculator and I take 150. Oops, that's the maximum, and there's 20 lines. So if I divide that by 20, I get each line could be 7.5. So I'm going to do every other. So this would be 15, and then 30. Skip a line, and then 45. And remember, it's the lines, not the spaces. 60, 75, 90, 105, 120, 135, and at the very top would be my 150. So I have all my lines labeled here. So where did we leave off? Okay, so we did this. Number the intervals. Title on the graph. I'm not sure exactly if this is tickets for a movie theater or for a show, but title could be like, just maybe I'm going to call it ticket costs. And now they want me to plot the points. So again, I'm going to 1 on my X and up to 15 on the Y. And I'm going to put my first point. And then 4 and 60. So I'm trying to be super accurate. And these are all going to fall really nicely on my intersections. 7 and up to 105. And 10 up to 150. So now it says decide if the points should or should not be connected. So again, I'm looking at these titles. Can I buy part of a ticket? No. I could have part of cost. I could have something that's $7.50 or 38 cents. So I could have parts for cost, but I can't buy part of a ticket. So they should not be connected. And that says when deciding, we're thinking about discrete or continuous. If it should not be connected, if we don't connect, that is discrete data. So I know my data here is discrete. Does the cost of the tickets vary directly with the number of tickets purchased? So again, when I see this word, these are the two things I need to think about. Did I get a straight line? And when we look at that, if I were to line those up, it certainly would be straight. So did we get a straight line? Yes. Did it go through the origin? We don't have that point marked on here, but would it make sense to? If I purchased 0 tickets, would the cost be 0? Yeah, it would. So I could add 0, 0 to this. So yes. So because these are both yeses, it does vary directly. It's directly proportional. It's direct variation. Those all mean the same. Now they want me to determine the constant. So they want me to write the ratio y over x for each entry. Now I know there's a constant because if we get direct variation, I know there's a constant. So I could check this with each one and write y over x. 15 over 1 is 15. 60 over 4 is 15. 105 over 7 is 15. 150 over 10 is 15. I really didn't need to do that though, because I know it varies directly. Then I know it's a straight line. Then I know I'm getting a constant. So we just figured out though that we get 15. We simplified each ratio, and did we get a constant? Yes. Our constant, which is k, is 15. So now they want to know, what does that constant mean in this problem situation? Explain the meaning of our numerator and denominator is our hint. So there is no numerator and denominator, it's 15, but I can make it look like 1 by putting a 1 underneath. And I know constant is y over x. So if I go up either to my graph and grab the label for my y or from my table, it's total cost. So y is total cost. And the x, either from my graph or from my table, is number of tickets purchased. So x is number of tickets purchased. So what does this mean? It means 15 cost. So that's $15 per one ticket. So per ticket. So again, we're always thinking about unit rate when we're describing this. So number 5, write an equation representing the relationship between ticket cost and number of tickets. So again, I'm going to go back to my constant. It's 15 over 1, and that was equal to tickets. I'm going to call that T, and I'm going to call the cost C. So 15 is the tickets, 15 is the cost. 1 is the tickets. I'm going to use means and extremes. 1C, which is C, equals the extremes 15 times T, 15T. Here's my equation. The cost is equal to $15 times every ticket that I order. Should make sense. Now they want me to use the equation, so I'm going to rewrite it. To determine how many tickets would be purchased if the total cost is $270. So that means $270 has to go in place of my C. $270 equals 15T. Now I need to isolate my variables. I'm going to divide both sides by 15. 270 divided by 15 is 18 equals T. It's great, but I kind of want to know more in words to get a really good score. What does this mean? It means I can buy 18 tickets for the $270. Now they want me to interpret the meaning of point 12, 180. So I know in an ordered pair again, first is x, second is y. When I look back up at either my graph or my table, x is tickets and y is cost. So x is tickets, y is cost. So that means 12 tickets cost $180. That's what the interpretation of that point. So if I went up here, and if my graph extended to 12, it would be 12 tickets, and the cost then would be $180.